Previously, we've been dealing with algebraic expressions that only have one unknown. For example, we have this expression 2x plus 3 is equal to 4. We have an expression of 4x plus 1 is equal to 3. All these algebraic expressions just have x as the unknown. So this is an algebraic expression with one term as an unknown, a variable x. So we can easily find the value of x. Even here, we can easily find the value of x. The expression only has one unknown. But now there are algebraic expressions that have more than one unknown, such as this one. Now, when it comes to such algebraic expressions that are having more than one unknown, it becomes tricky for us to find this value of x or to find this value of y just using this one unknown. So now, how do we find the value of x and y? Now, we can only find the value of x and y if a second equation is introduced, and this second equation that is introduced must also be having the unknown x and the unknown y. Now, when this second equation is introduced and now they become two equations, now those two equations are what we call simultaneous equations. So in general, simultaneous equations can be defined as a set of equations having two or more unknown variables. The unknown variables can be in various forms. The unknown variables can be 2, they can be 3. Now, in this series of videos, we shall be dealing with simultaneous equations. Thanks for tuning in. This is Kisembo Academy. Now, the simultaneous equations, like I had earlier said, can be in various forms. We can have simultaneous equations that only have two variables, that is x and y. It means for us to be able to find the value of x and y, we are supposed to solve these two equations simultaneously. We can also have simultaneous equations that are having three variables, x, y, and z. So we have x, y, and z, and there are three equations. So we solve these three equations simultaneously to find the values of x, y, and z. Before we were looking at algebraic expressions with just one variable. For example, if you look at this equation, we have 2x plus 3 is equal to 4. To find the value of x, it means, of course, we are going to shift 3 to go that side. Of course, when we shift 3 to go that side, it becomes here 4 minus 3. We remain with 2x on this side. When we divide both sides by 2 here, we shall end up with our value of x as a half. That is when we are having one variable in the algebraic expression. But what about when we have two? We are having two variables. For example, in this equation, we have x and y. We can't simply easily get the value of x or the value of y unless we introduce a second equation so that we solve the two equations simultaneously. So, in this video, we shall be dealing with simultaneous equations first that are having two variables. Now, there are various methods we can use to solve simultaneous equations that are having two variables, such as these. These are the methods we shall be exploring throughout this series of videos. We shall look at the graphical method, the substitution method, the matrix method, and the elimination method. So in our upcoming videos, we shall explore each and every method stipulated here in detail with illustrative examples. This has been just an introduction. Thanks for tuning in. This marks the end of this video. Up next will be more of this. I urge you to stay tuned in. For more videos, please remember to subscribe. This is Arnold Rangakuramia on behalf of Kisembo Academy.